we're on 2018 FRQ number 5, still in the non-calculator section. It says, let f be the function defined by f of x equals e to the x cosine x. Part A says find the average rate of change of f on the interval between 0 to pi. So average rate of change is just another way to say slope. So we're going to have to find the y values of these two x values. So we're going to start by saying f of pi equals e to the pi cosine of pi. That's negative e to the pi. F of 0, we get e to the 0 cosine of 0. E to the 0 is 1 times 1, that's 1. So the average rate of change will be y2 minus y1 over x2 minus x1. So negative e to the pi minus 1 over pi. Not a very clean answer, but that's the answer. Okay. All right, what is the slope of the line tangent to the graph of f at x equals 3 pi over 2? So the word tangent tells us we're going to take the first derivative. So f prime, I'm going to change color so you know it's the second problem here. F prime of x, we're going to use product rule because there's product here. So e to the x, right? E to the x is the derivative of e to the x. So we took the derivative of e to the x times cosine x. And then you now need to take the derivative of cosine. So it's negative sine x times e to the x, right? Plug in 3 pi over 2. So f prime of 3 pi over 2 equals e to the 3 pi over 2 cosine of 3 pi over 2 minus sine of 3 pi over 2 e to the 3 pi over 2. Cosine of 3 pi over 2 is 0, so that is gone. And then 3 pi, sine of 3 pi over 2 is negative 1. Negative 1 is positive. So my answer is e to the 3 pi over 2, and that's your slope. Very gross answers. Okay, next, part C. Find the absolute minimum value of f on the interval between 0 to 2 pi. Justify your answer. So remember, you need to find the first derivative, which we already did in part B, set equal to 0 to find your extrema. But since this is a closed interval, you must check against the endpoints, all right? So we're going to go for part C here. Part C, and my f prime, since they both have an e to the x, I'm going to factor that out and make it so that it's e to the x, parentheses, cosine of x minus sine of x. All right, now we're going to solve for extrema, so set equal to 0. So you set them separately, e to the x equals 0, and e0 equals cosine x minus sine x. Well, e to the x will never equal 0, so that one will not give you any extrema. So now we're going to focus on cosine and sine x. So there's a couple ways to solve for this. You can go ahead and put sine x equal cosine x and ask yourself, when is sine x equals cosine x? Well, at pi over 4. And if you look at, remember this is between 0 to 2 pi, so it's a full unit circle. So it's in quadrant 3. That will be 5 pi over 4. Another way would be to divide both sides by cosine, and therefore you get tangent of x equals 1. And then you ask yourself, when is tangent equal 1? And you'll get the same answer too. So that's another way to do it, okay? So or. All right, so those are my two extrema. Now I gotta check and see if they are truly my maximums, right? So you would make a t-table, and using this space over here, f of x and x. So I'll check the endpoints, 0, check my extrema, pi over 4, 5 pi over 4, and then 2 pi. And then plug into my function, which is up here, e to the x cosine x, right? So we know f of 0, we already did that. F of 0 up here was 1, right? We got that answer from part A here, 1. And then how about pi over 4? So it's e to the pi over 4. Cosine of pi over 4 is root 2 over 2. Okay. E to the 5 pi over 4. Cosine of 5 pi over 4 is negative root 2 over 2. And then 2 pi e to the 2 pi. Cosine 2 pi is 1. So e to the 2 pi. Okay. So which one is an absolute minimum value? Well, all these are positive except this one. This is minimum. This is the negative value. So this must be my minimum, right? So that is my absolute value. So I would say the absolute value, absolute min of negative root 2 over 2 e to the 5 pi over 4 at x equals 5 pi over 4. That's a very awesome answer. Okay. Do I have enough room? Yes. All right, part D. Let g be a differentiable function such that g of pi over 2 equals 0. The graph of g prime, the derivative of g is shown below. Find the value of limit as x approaches pi over 2, f of x over g of x, or state that it does not exist. Justify your answer. So we're going back to limit. Limit as x approaches pi over 2 of f of x over g of x. Right, remember what we do when we have limits? You plug it in, right? So we're going to plug in f of pi over 2 and look for g of pi over 2. Okay, well, f of pi over 2, if we look up here, my function is e to the x cosine x. So off this side, I'm going to work that out. So e to the pi over 2 cosine of pi over 2. Well, cosine of pi over 2 is 0, so that's e to the pi over 2 times 0. So that gives me 0. And then the problem says g of pi over 2 is defined to be 0. So we have a 0 over 0. This is an indeterminate form. We must use L'Hopital's rule. So L'Hopital's rule says limit as x approaches pi over 2 of f prime over g prime of x. Okay, we did take f prime. F prime is over here, this function right here. So we can use that. So we're going to plug in pi over 2 again to now the derivative. So again, off to the side, I'm going to work that out. So I'm working out f prime of pi over 2. That would give me e to the pi over 2 cosine of pi over 2 minus sine of pi over 2. Okay, so e to the pi over 2, cosine of pi over 2 is 0, sine of pi over 2 is 1, so times negative 1, so negative e to the pi over 2. So negative e to the pi over 2, and then g prime of x, so look at g prime of pi over 2. So here at our graph here, g prime of pi over 2, so at pi over 2, right, what is my slope? So g prime of pi over 2, oh, sorry. So at this graph is the graph of g prime. So we just look at the y value of pi over 2. So pi over 2, the y value is 2. And that's it. It's not an indeterminate form. We actually have a limit. Granted, it's pretty gross. Okay? All right, that's it for this problem.